So in order to figure out which of the acids you have on this list, what you're going to do is you're going to compare all of these acids to your unknown, to your acquired data that you've done experimentally. So you're going to take all of this information, you're going to copy it, and you're going to just paste it in Excel. So here is the entire array of acids, their molecular weight, and their pKa's. So let's say you have experimentally found 134 and 445. You can go through the list and say it's 445 is closer to this, but this molecular weight is better. And so we're not going to actually select it that way. That is the incorrect way to select it. We're going to let math and science select it. So we're going to calculate the percent error in the molecular weight for each one of these, and we're going to calculate the percent error in the pKa for each one of these. So if you remember, your error in the molecular weight, right, will be the absolute value of the molecular weight minus, or what we consider real, minus our experimental, divided by the real number, multiplied by 100. And here you can see we've calculated the percent error. Now notice I've chosen 134 as my number of the one I've experimentally decided, and I've locked that in place. So that allows me to quickly, for everything, just fill down and calculate the percent error for everything. So you can see that that's just this. We're going to do the same thing with pKa, but instead we're just going to drag this over. Click in here, you'll see now the pKa is moved, but we need this to be the pKa. We can either change this to a C, or we can just take the red box and drag it over. And now we've calculated the percent error for all of the pKa's as well. So we want to do it on both of these combined, so we're going to take a sum of these, and we're just going to simply say, oh, we're going to take this error, sum it with this error to get an overall error. And then we're going to pick the lowest one. I think you can see already it's that 8, but what the hell? Might as well just have the computer do a little more work for us. We can rank them. We're going to rank this number out of this array. And once again, we'll have to use the $signs to lock that in place. And we want it in the order such the smallest number has the highest rank. So there we go. We can see that this is the rank 1, and rank 2 is 13. So now you would pick acid H as your acid. But let's say, hey, you know, I had one of my molecular weight measurements was a little bit off. So let's say my 134 comes from, I don't know, two measurements of 133, and you had a 136, okay, or something like that, and your average, and you think that 136 is off. Well, you can always say, well, imagine if I didn't have this, it would be 133. You can change this to 133. You'll notice that in this case, it doesn't move at all. So even with this error in place, it does not affect the final answer. In fact, you can then go through and say, hey, what range would I need? Is 130 enough to keep it? Yeah, you can go as low as 130 or maybe 140. It's still good enough to keep it. What about the pKa? How much would the pKa have to shift? Could you go down to 4.0? Nope, it would move. It would move to something else. So 4.0 would be too far down. So this is how you're going to select your acid, which is basically just the sum of the percent error, so your accuracy.